time that World War II was breaking out in 1930. His parents were both anarchists, so he got most of his anarchy blood from them. And so when World War II broke out, his dad and parents ran to France to avoid Nazism. They didn't want to have anything to do with it. And I think at that time France was taken over by the Germans, so they were sent to concentration camps. But apparently they were treated rather well. Like Grothendieck was put into a daycare center at the concentration camp and wasn't killed or anything, obviously. Although I think his dad did end up dying in a war, which made Grothendieck, of course, very mad and upset. And when he was actually in the concentration camp, he broke out at around age 15 and tried to assassinate Hitler himself. And of course that failed miserably because he was a 15-year-old kid, but it's just a really bold move from just a kid. So that was a really cool story about him. Okay, any questions about any of these other people that I listed and didn't talk about? Probably not.
Can you explain in something that I might be able to understand what the Poincare conjecture tries to conject?
The way I understand it is that you're able to, so, I can't, I just don't know. There's no explaining applied for that.
And then what is your favorite, like, explainable, either conjecture or theorem or something?
That's a good question. I don't think there's a really good explain like on 5 for any of these topics.
Luckily we're not 5.
Explain like on
Give me a
22. Okay. What was I going to talk about? I think it was Cardano, who the tale I was told back then was he had some sort of memories about killing his mother or something like that, and it basically like every once a week or whatever he was just leaving, he would just not show up for work because he was so tormented by the street. And actually, wait, was that Cardano? I know it started with a C. Regardless, I'll give you a topic about Galois theory. So, you know, like about the roots of polynomials. That's a pretty common topic. He came up with an idea that you can make a polynomial into a product of 2 polynomials at a smaller degree. That was basically his idea. And like, when is that possible? This is the whole branch of Galois theory. When can we factor polynomials into smaller polynomials? And he basically ended up creating some sort of substantial area of research that's sort of number theory and sort of not number theory, because Galois theory is sort of hit and miss a lot of the time, where there are cases that does work and there are cases where you have no idea what you're doing, nothing makes sense. So it's still like a pretty undeveloped field, but for the most part it is just about factoring of polynomials. So, which seems like some sort of an elementary topic, but there's lots of polynomials like x to the 5th minus x minus 1, where the solutions cannot be expressed in radicals, which is somewhat strange, because the coefficients are all integers, so it's just sort of a weird idea that there are, I don't want to get too into this stuff without just being obnoxious, because if I start talking about algebraic numbers, it will just be obnoxious. Okay, I guess for the Bernoullis, which I missed out on, they're a big family of mathematicians and physicists, and really obnoxious guys with big egos. And they'll forever be known as that. And one day, Jacob Bernoulli was teaching Euler, Franz Euler. And it came across this problem for compound interest, that like, you could calculate compound interest with this sum, this limit, and basically they're like, we can't figure this out. Like, it's approximately 1 in 3/5, something like that. And Euler's like, all right, give me a day or 2. And like a day or 2 later, like, the problem that stumped the entire Bernoulli family, Euler did in like 10 minutes. And from there on out, the Bernoullis were always like, in your face, they were better than Euler. No, Euler just kind of did his own things, he didn't really give a shit. And later into Euler's career, he actually became blind. And even in his days of being blind in both eyes, he was a more proficient mathematician than all the Bernoulli family. So these guys worked very hard. They were architects. I think like the last Bernoulli family member was in the 1800s, like that was 200 years of Bernoullis. And he was an architect. I think he died unwed, so I don't think they ever carried on. But the Bernoullis were famous for the probability statistics, fluid mechanics, the types of things where you have springs and those kind of things. And basically, whenever they gave people other problems, he did them in like 10 minutes because he didn't ever care about anything. And so they were switching between, around this time, in Euler's life and in mathematics history, the main source of mathematics was France, Germany, and Russia, as anyone would expect. And then there was one place in Switzerland, which was in Basel, or maybe it's Sweden. I think it's Switzerland. Basel. And Euler was going between Basel, Germany, and Russia the entire time. And finally, the Bernoullis, I guess, had left out of fear. So Euler took their place in Basel, and there was a big problem called the Basel problem, of course. And it was the sum of 1 over n squared, of like 1 over 1 plus 1 over 4 plus 1 over 9 to infinity. And they couldn't figure it out. Like, it's probably like 8/5 or something. They gave us some really weird approximation. They probably had done it by hand and approximated it. And I came across this really cool method that was using sines and cosines, which didn't make any sense. Like, why would you use sines and cosines to solve that? And he realized it was pi squared over 6. And once again, this actually won him his fame and recognition. And the Bernoullis kind of shut their mouths again because Euler showed them up as usual. So the Bernoullis were always sort of in their face about being greater than him, and he just kind of did his math because he didn't care about popularity or recognition, which is cool. I miss John Nash. John Nash was, I think, the movie A Beautiful Mind is about him. I'm not sure any of you have seen that.
Yeah, I love that.
John Nash was a mathematician and what?
He was the one with schizophrenia, right?
Yes, he was schizophrenic.
That was.
Yes. So he married schizophrenia about it. He did a lot of math. He won a Nobel Prize. Went to a mental institution for like 20 years in a mental institution. Finally got out, remarried his wife, and then did some more math. He actually would sit in on classes at Princeton as a student when he was in like his 70s. He's like, I just want to learn. And the professor teaching like undergraduate calculus, and I guess he had forgotten it because of his mental illness, which is really depressing because he was probably one of the most prolific mathematicians in the area of probability and game theory and stuff in the 1970s, I don't know, 60s. And then in 2015, he got in a car crash, and that was unfortunately the end of John Nash. But he did live a life of schizophrenia and paranoia, and it was really sad because he was a very smart man. Any questions about anything I've rambled on about?
Is there just correlation or causation of mathematics?
I think there's a correlation, at least with Gregory Charlemagne, Grothendieck, and Pythagoras. I would definitely say there's a correlation between those three. I don't know if it's a good line, but there's some sort of curve there that they pair up with. Oh, and Miss Ramanujan also. He died before his 35th birthday or something. I'm not sure if any of you have heard of him. Has any of you heard of him? Have any of you heard of him? Mr. Ramanujan, probably from me. So none of you have heard of him. He was a very poor man in India, living with his parents, because he did that in India, that was what he did. And he picked up a book one day, like a book of 5,000 theorems. It was called Carr's Book of Theorems. And it was literally 5,000 theorems in a row in the book, nothing interesting about it, very dry. And he read the book over and over again. And sooner or later, he understood the numbers. He understood how numbers work. And he wrote a letter to mathematicians around the world. He's like, I want to do some more math. And his parents were like, math is worthless, you're never getting worth math. And finally, the mathematician at Cambridge, G.H. Hardy, answered him. And he's like, there's no way this can be made up. This is not fake. Like, you can't make this kind of stuff up. It's too like in depth. Like this, if you turn things up, it wouldn't. It doesn't make sense to make this up. It's too concise. So he's like, okay, get this guy over here now. Like, I'll give you all of my funds from Cambridge. Just get him over here. And at first, like I can't go. I have to stay with my mother. If I go over there, I'll be ruled a traitor in India. Those kind of things for even going overseas. It was like anti-sacrilegious and stuff like that. And he went to Cambridge, where he couldn't prove a thing. So J. Hardy basically like nailed like a hammer and nail, trying to make proofs out of him. And he wouldn't prove anything because he couldn't prove anything. He basically said that when he proved it, when he had a theorem, it was because God gave it to him. That was his whole reasoning for everything. Whenever he had any kind of insight, he said God gave it to him in a dream. So J. Hardy would sit there and he's like, prove it, just please give me a proof. Like he's like, I don't care, I don't want you to do anything else, just give me a proof. Just sit in the room and prove things. And after a while, Bernard Russell, that's his name. Okay, Bernard Russell, who was another great mathematician. Well, I'm sure I'm way out of my list of mathematicians that I should reference him that you guys don't know about. He said you probably should be nicer to him. Like he's a smart kid, you gotta just give him a chance to like work his way in. And what happened was, soon into his career, he got into religious issues, And he wasn't eating in Cambridge because he couldn't eat certain meats, and like there was a lot of different foods that he couldn't eat. So he basically was eating nothing the entire time. Like he'd eat crackers, and that was it. And he would do his prayers, and G.H. Hardy was totally anti-religion. Like there's no God, there's no such thing as God ever, and that's anything you say about it is ridiculous. And Ramanujan was like, well, religion, disagree. And then 2 years later, after Ramanujan had spent 2 years in Cambridge, he got very sick with tuberculosis, and I believe he died in India with his family, luckily. So, but he was probably one of the smartest mathematicians in number theory in the early 20th century, so it was 1900s. And he just lived a very short life of just very good work, as well as Eisenstein, who I mentioned. There's a period of his life known as the prolific 5 years, where for 5 years he did an insane amount of good work before he died. Like he was on a roll for five years straight, just nonstop math, nonstop good results, and then he just, at the end of it, he died, which was really unfortunate because he was just pumping out results in papers, like 20, I think he published like 23 papers in 5 years, which is an insane amount of work. Yeah. So he just kept publishing, and it was all good stuff. And then, unfortunately, yeah. Alrighty, I think that's probably, I'm sure you guys have had enough hearing about mathematicians that are obscure.
Do you think that if you look at any field, you'll find like a lot of views and crazy people, or do you think that math specifically just has a lot for whatever reason?
Boltzmann, who I mentioned, is a physicist. Von Neumann's a physicist. So physics definitely has a good tie-in. I mean, but then again, there's better physicists who are not insane. Like Richard Feynman's he's a nutty guy, but he's totally normal.
Quirky.
Yeah, he's just quirky.
So are most of these like theoretical mathematicians or applied, or I don't know, is there any rhyme or reason to being insane and doing theoretical work as opposed to applied work?
Bernoulli's were nutcases because they were all just egotistical. They did plenty of applied work. They worked with fluid dynamics, springs. Basically high school physics at this point was all by them. But at that point, it wasn't high school physics, it was PhD work. Tartaglia, Cardano, Ferrari. I mean, solving the cubic equation really isn't anything that anyone would ever really care about, say calculators. And back then, we could still solve it numerically. So it's just kind of a theoretical thing that we know about, because after the solution to the cubic equation came about, they used the same method a little differently to solve the